Hi everyone, and welcome to my video on literal equations. Literal equations are basically formulas. They are equations that have more than one variable. Typically, the variables represent something specific like length, width, height, time, things like that. So when we're solving literal equations, we're actually solving for a letter still. However, there will not be a number or value amount as your answer. So when we were solving just regular old equations, we would always get like x equals 4. Or when we did inequalities, we'd get x is less than or equal to 5. When we're solving literal equations, it's really just moving things away from the variable you're solving for. And they don't really go away. It's just like regrouping everything to one side versus the other. So it's all about how you manipulate and move the other letters and variables in order to get the special one by itself, the one you're looking for specifically. So we're just going to jump right in and start with this formula right here. This is the volume of a box. Now, a lot of these formulas will seem unfamiliar and kind of weird.
Teachers, please release group.
You'll see a lot of them next year in geometry. So right now, we're really just worried about being able to solve literal equations, so move letters around. This one, we're going to solve for height. So I like to circle, especially during literal when there's a lot of letters, I like to circle the one I'm looking for. So I'm looking for height. I want to get height by itself. In order to do that, I see here that I have length times width times height. So in order to move the length and the width away from height, all I have to do is divide by length times width. And that cancels those out because anything divided by itself equals 1. So my height equals volume over length times width. And that's all you have to do. So it's just moving all the other letters away from the one that you want by itself. We just have to make sure we use correct operations in doing so. So let's look at the volume of a cone. The volume equals 1/3 pi r squared h. And we are solving for the radius, which would be r here. First thing I want to do is I would like to move that fraction. So to do that, I'm going to choose to multiply by the reciprocal. Remember, that means you're flipping the fraction upside down. So I'm really like multiplying both sides by 3. So I want to make sure if I do it to one side, I do it to the other side. So this would be 3v equals, now I have pi r squared h that remains on the right side. The next thing, or two things I need to get rid of are the pi and the h. So just kind of like that first example, since all of these are being multiplied together, and I don't need to do anything fancy with the pi, I just leave it as the pi symbol. We don't need to worry about, oh, do I change it to 3.14? Nope, just leave it as the pi symbol. All we have to do is divide both sides by pi h. So again, I'm canceling out the other two things on that side, and I'm leaving r squared by itself now. So pi h is divided on both sides. That gives me 3v over pi h equals r squared. Now to get r by itself, I see r squared here. If I'm squaring something, to be able to undo that, or the opposite operation of it, would be to take the square root. So when I take the square root of r, square root cancels out the squared. And I don't need to do anything else to like pretty that up at all. I'm just going to say the radius r equals 3v over pi h. And that's it. So you're going to notice we don't really get pretty answers. They might look kind of like a hot mess, but the good thing is if it looks like that, that probably means we accomplished our goal. Let's look at the next one, area of a trapezoid. We are solving for height. So again, I'm going to circle the one I'm solving for. You might be tempted to say here, ooh, I see parentheses, so I probably need to distribute, because that's exactly what we should do when we're solving regular equations. For these, that will probably complicate this way more than we need to if we decided to distribute. So instead, we're going to do just like we did on the last one. We're going to cancel out our fraction first by multiplying both sides by 2 this time. So 1/2 times 2 would cancel. That's 1. And then I have 2a equals h, parentheses, b1 plus b2. Now, because this b1 plus b2 is grouped together in these parentheses, and it's being multiplied by h, all I have to do to get it to the other side is divide by b1 plus b2. So when I do that, they cancel on the right side. Anything divided by itself equals 1, so they cancel. And I end up with h equals 2a over b1 plus b2. And that is my final answer. So you'll notice that literal equations typically involve some sort of division. Sometimes they will also have like a fraction pretty regularly that you have to cancel out or move over as well. Okay, area of a triangle. So I see a fraction. Oh, I guess I should say what I'm solving for. We're solving for base. So circle B, I see a fraction. I want to handle that fraction first. So I'm going to multiply by 2 on both sides, which cancels on the right and gives me 2a equals bh. Now, if I divide both sides by h, I will get 2a over h equals b. And that is what my base is equal to. So we're just manipulating all those letters and moving them around. The next one, area of a rhombus. This is area equals 1/2 times d1, which stands for the diagonal 1, times diagonal 2. We're solving for diagonal 1. You probably are already anticipating this first step. We want to, again, get rid of that fraction by multiplying both sides by 2. Sorry. That cancels on the right and gives me 2a equals d1 times d2 on the right side. And now to get d1 by itself, I just divide by d2. So diagonal 2. Those cancel over there, and diagonal 1 equals 2a over d2. So those steps were actually exactly the same as the one above. We multiplied by the reciprocal of our fraction, and then we just had to divide by the other variable. So actually ended up being the exact same steps, just with different letters. We have a couple more that we're going to do here. We are heading into our linear functions unit. So we will spend a lot of time with slope-intercept form and a couple different forms of linear functions. So since this is one we are familiar with, we wanted to use this as an example as well. So for this one, we're going to solve for the slope. This is our first one where we've actually had like addition as an operation, not just straight across multiplication. So this one actually ends up being a little different. Since mx is grouped together right here because of multiplication, I can't really do anything with those. I can't separate those yet until they're the only thing on their side. So first I need to subtract b from both sides. Now, I don't know about you guys, but I have no clue how you would take a letter away from a letter. It's not like numbers. I can do 4 minus 2 all day long, but y minus b, we can't take a letter away from a letter. So they just stay as y minus b. We can't simplify that at all. They're different letters. They can't combine at all. So they just stay as y minus b. And then I have it's equal to mx. I'm going to divide by x to finish getting m, the slope, by itself. So m equals y minus b over x. And then the last one we're going to look at here is an example in something called standard form, which we haven't gotten to yet, but we will soon in our linear functions unit. In that unit, I'm going to start this one because we will do this until we're experts at it, but we're going to solve for y. So this is kind of another application of this process where we're solving for different letters in different formulas or equations. So for this one, we're going to solve for y. 3y is stuck together. They can't be separated until they're the only thing on their side. So that means I need to move this group right here, 6x, over to the other side. And to do that, we're going to subtract it. We subtract that term to the other side. So I drop down 3y, and it's equal to 24 minus 6x. Since there's an x on the 6, I can't take away an x from a term that doesn't have an x in it. So that's why we just keep them separated out as 24 minus 6x. Now my last step is to divide both sides by 3 to finish getting y by itself. And I like to write it under each term to make sure that I do a really good job of simplifying. If I didn't write it like that and I wrote it like this, where the whole thing, the whole numerator is over 3, I may not be able to recognize as quickly, oh, hey, these are both 6 and 24 are divisible by 3. So that's why I like to write it out separately. That way I know for sure I'm not going to miss my simplifying there. So last step is to simplify. 24 divided by 3 is 8. And then I'm going to subtract 6x divided by 3 would be 2x. So that would be my final answer solving for y. We are going to do